Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to improve our math skill. We do few math problems which will sharpen your skills that you need, which will sharpen your skill, and it will make sure that you have the basic concepts of math at your fingertips. If you're preparing for SAT, GRE or GMAT, it doesn't matter. Today is our day number 28. Let's take a look at the problem and then we'll see what we can do with it. Here's the problem. A right-angled triangle is such that its sides are 3 consecutive odd or even integers. All we know is that the sides are 3 consecutive numbers, 3 consecutive odd or even. For example, it could be 13, 14, 15, or 20, 22. 13, 14, 15 won't work. They're not 3 consecutive numbers, they are 3 consecutive odd or even. So it could be 13, 15, 17 if that works. Or it could be 20, 22 and 24 if that works. That's the big if. But we know that it's a right angle triangle and its sides are 3 consecutive odd or even integers. The question simply is, what is its perimeter? Very simple, very straightforward problem. What I want you to do at this point is to pause the video, solve the problem yourself, do whatever it is that you have to do. Once you have the solution, you can resume the video. But do not watch the solution until you have solved it yourself. Do you understand? I'll give you a few seconds to pause and unpause and so forth. I'll be right back. Alright. So again, one more time I'm reminding you, if you have not done so already, do not continue watching the solution. Just stop the video at this point, solve the problem yourself, and then go from there. So here's our right angle triangle. Let's draw one. So we know it's a right angle triangle. Very first thing we have to understand is that how do we express in the algebraic language, because that's what it is, algebra is language, mathematics is a language. How do we express in the algebraic language, in the language of the algebra, the concept, the notion of 3 consecutive odd or even numbers? But before we talk about 3 consecutive odd or even numbers, let's talk about how we represent 3 consecutive numbers. 3 consecutive numbers, for example, if there are 3 of them, you cannot go around saying A, B and C. That doesn't work. As I told you before, it is a language. What you have told me just now here is that you have 3 numbers and they have absolutely nothing to do with each other, which is not the case. If there were 3 consecutive numbers, then if the first one is A, and if they're consecutive, the next one would have to be one more than that. That's how we express this. It's not A and B. A and B means that they have nothing to do with each other at all. Now if this one is A plus 1, then the one after that, if there are 3 consecutive ones, then one after that will have to be one more than that, which is A plus 1 plus 1, or A plus 2. Here we have 3, not 3 consecutive numbers, but 3 consecutive odd or even numbers. How do we represent it? For example, if we say that the first one is, if we're going to say that the first one is X, if first one is X, for example, if it is 9, say for example, and we are expressing the next odd one, the next consecutive odd integer would be 11, which is 2 more than that, so it's going to be X plus 2. And the one after that is going to be 13, which is 4 more than this, X plus 4, or 2 more than that. So the first number is X, the next one is X plus 2, 2 more than the first one, and the one after that is x plus 4, 2 more than this one, and therefore the 4 more than the very first one. That's what we have here. So let's put them in our triangle. Where does x go? X goes to the smallest side. Where does x plus 4 go? X plus 4 will represent the biggest side of the triangle, and in this triangle, the largest side is the side facing the right angle, namely the hypotenuse, x plus 4. And then this is our x plus 2. Now the question is, what are we going to do with this thing? How do we find out what they are? Well, by using this notion called Pythagorean theorem. Pythagorean theorem tells us that the square of these two sides, the sum of the squares of these two sides must equal the square of the hypotenuse. So that's what we're going to do. The square of these two sides, the square of this side and the square of that side must equal the square of that side. And now we have to solve for x. There is a lot going on in this problem. It's an algebra problem, it's a geometry problem. You're going to have to deal with factorization, you're going to have to deal with several different concepts here, which is why it's a good practice, because if you can handle something like this, you can handle pretty much anything that you're going to find on the SAT, GRE and GMAT, at least the easy and the medium questions, if not the hard ones. You understand? So it's just for the purposes of practicing, getting your algebraic skill and geometric skill sharpened. So let's continue then. So this is just x squared, and when we open this thing, it's just a plus b whole squared. That's how it's read, a plus b whole squared, which is a squared plus 2ab plus b squared, which is what we're going to do here. Here our a is x, and our b is 2, x plus 2. So x squared plus 2 times a plus times b, 2 times x with 2x times 2 is 4, plus b squared, which is 4, 2 squared, and that has to equal this guy, x squared plus, I'm running out of room here, so I'm going to erase this part here. I'm going to erase all of this thing, you understand it. Because I'm running out of room. X squared plus 2 times x times 4, which is 8x, plus 4 squared, which is 16. Voila. Let's combine the like terms together, and let's get going. So here I see x squared, here I see x squared. If we were to subtract x squared from both sides, the first x squared will drop out. If we subtract x squared from both sides, this will drop out. But we still have this x squared. So x squared 4x minus 8x will give us negative 4x, and then 4 minus 16 will give us negative 12. Now we have to solve for x. This is called quadratic equation. Now we have to solve for x. So I'm going to do this part on the top here. I'm going to erase the problem. You already have the problem. I'm going to read it one more time. A right angle triangle is such that its sides are 3 consecutive odd or even integers. Question simply is, what is the perimeter of that right angle triangle? We do not know whether there are 3 consecutive odd integers or 3 consecutive even integers, but we do know that 3 sides are 3 consecutive odd or even integers. Question simply was, what is the perimeter of it? And for that we need to find out what this x is. So I'm going to erase this top part here and continue solving this part here. I do not know why it does not erase properly today, for some strange reason. Okay, so we're going to continue this part here. This is what is known as a quadratic equation. And there are 2 or 3 different ways you can solve this problem. One is by using what is known as the quadratic formula. Another one is by using what is known as factorization. in the factorizations we find what it says. We find the factors of it. And the way we do that is that we are looking for two numbers. I'm going to write as I speak here. This part tells us that we are looking for two numbers whose product is -12. When we multiply them, we have to get -12. And this part tells us that we're looking for two numbers, the same two numbers obviously. Those two numbers have to be such that those two numbers have to be, I don't like this pens, have to be such that they add up to -4. It's very important that you pay attention here, -4. And here the product was -12. Now our job is to find those two numbers. What could be the two numbers whose product would be -12, and whose sum would be -4? Well, let's take a look. It's very simple, very straightforward. It is 12. Let's see if I can do it here. Well, let's start here. The first thing that we do is divide by 2. You get 6. 2 and 6. Let's see if that works. 2 and 6. Well, their product is 12, obviously. But we want a -12. We want a -12, which means one of them will have to be negative, other one will have to be positive. If that's the case, -4 and +6, do they add up to -4? No, they do not. A -2 and a +6 will not add up to -4 because they have to add up to -4, which tells us that this does not work. This tells us that we need this, +2 and a -6. This doesn't work. So that's what it is, +2 and -6. So we're going to continue here. Where should I? +2 and -6 are factors, and I'm going to continue on the top here. This you already saw it here, so I need the room, so I'm going to erase it. I shouldn't have done all of this here. Let's put it here. So we have 12, which can be broken up into 2 and a 6. And since we want them to add up to -4, my first instinct was to put a negative in front of the 2, but that gives us +4, so that does not work. We need -4, so this has to be +2 and a -6. This doesn't work. So those are the factors, +2 and -6. Let's continue here. I am going to do it in a very different way than what most American kids are told. They're just asked to memorize this thing, and they simply, this is what I have seen kids do. They write this. Here's what the equation is. And then they simply do this. And they sit there and look for the two numbers and put down the two numbers there, and that's it. That's a lazy man's out. That is a very lazy way because you do not understand. You're not understanding the mechanics of it, what goes behind the curtains. You must show the work. So that's what we're going to do. We're going to show the work. The two factors are +2 and -6. So here we go. X squared plus 2x, that's your +2, minus 6x, which is our -6, minus 12 equals 0. As you can see, +2, +2x, and a -6x will give us -4x, and a +2x times a -6x is going to give us the -12x times x squared. Now I want you to look at these two terms together and see if you can find anything common. I need to erase all of these things because we need the room. What do you find common in these two terms? These are called terms. What do you find common? We find x common. If I take out the x common here, we're left with x because x times x is going to give us x squared. Plus, if you take out x common from the second term, you're left with 2. You see? 2 times x is going to give us the 2x. What do you find common in these two terms? What do you find common in these two terms? Well, I see a -6 and a -12. What common factors do they have? Well, -6. So take out -6. If you take out -6, what are we left here? We're left with x. As you can see, -6 times x is going to give us -6x. And then once you take out -6 times what number is going to give us -12? -6 times a +2 is going to give us the -12 that we need. Now I want you to look at these two terms. What do you find common in this thing? Well, I see x plus 2 here and x plus 2 here. We're going to take that out common. Again, I'm going to erase it because it's getting too crowded. So let's take it out. X plus 2 we're going to take out common. If we take out x plus 2, what are we left in this? This is one factor now. What are we left here? We took out x plus 2 common, so we're left with x. As you can see, x plus 2 times x is going to give us this part. And then -6. Here we're left with only -6. X plus 2 times the -6, which is this second part here. That's it. Those are your two factors. And all of this has to equal to 0. So if I have two quantities and I'm told that their product is 0, if you have two quantities and when you multiply them and you get an answer 0, there are only two possibilities, which is either x plus 2 equals 0 or x minus 6 equals 0. Or actually there is one more possibility, or they both equal 0, which means x plus 2 equals 0 and x minus 6 equals 0, because 0 times 0 would also be 0. So there are three possibilities. If x plus 2 is equal to 0, then x would have to be -2, and if x minus 6 is 0, then x would have to be +6. This possibility of -2, x being a -2 in our case, is purely for theoretical purposes. Why? Because here we're dealing with a triangle with three sides, and sides of a triangle, or for that matter side of any shape, cannot be a negative number. We are dealing with something that has to have a positive value, therefore our x is 6. If our x is 6, let's see, where should we put it? If our x is 6, I'm going to erase this part too. I need the room. If our x is 6, then the next side, next bigger side, which was x plus 2, would have to be 8. And therefore the hypotenuse would have to be x plus 4, which is 10. There is your triangle. 6, 8, 10. Do you recognize anything here? The triangle that we're dealing with has three consecutive even integers, not odd integers, and they are 6, 8, and 10. And therefore the question simply was, what's the parameter of this triangle? The answer is 6 plus 8 plus 10, 24. That was the answer. But do you recognize anything here? For those of you who were quick enough, you might have seen it from the very beginning, that the only way we're going to get three consecutive even integers or odd integers to be the size of a right angle triangle is if we are dealing with a very simple 3, 4, 5 triangle. That's a 3, 4, 5 triangle incognito. This is the 3, 4, 5 triangle. Incognito, in disguise. It's just a 3, 4, 5 triangle which has been enlarged 100%. As you can see, if you have a 3, 4, 5 triangle, then 3 times 2 gives us a 6, 4 times 2 gives us our 8, and 5 times 2 gives us our 10. For those people who were quick enough to realize that from the very beginning, they didn't have to do any of this thing. The only way you can find a right angle triangle with three consecutive odd integers would not work at all. Three consecutive even integers is if you started out with three consecutive integers And the only possibility for a right angle triangle where it contains three sides with three consecutive integers are, well, not are rather, is, because it's the only possibility, 3, 4, 5. The universe, the nature did not create any other right angle triangle with three consecutive integers. There is no such thing as 7, 8, 9. There is no such thing as 12, 13, 14. There is only one right angle triangle that the nature created where the three sides have to be three consecutive integers, and that is 3, 4, 5. And therefore, if you multiply that by 2, you will get your triangle that you're looking for, the three consecutive even integers, namely 6, 8, and 10. That's all. We're done. I hope you got something out of it. If nothing else, at least you, as I said before, the purpose of this problem is to just to exercise your brain and just practice the math problem and practice your math, because these problems have everything. We're not doing a geometry problem. We're not doing an algebra problem. It has a little bit of everything. And if you can do this, if you can do something like this on your own within a reasonable amount of time, then you're doing quite well. You know? Anyway, if you wish to get hold of me for personal private tutoring, I tutor for SAT, GRE, GMAT, and TOEFL, of course. You can go to any of these website addresses and send me an email, or you can simply go to keshwaniprep.com and you can get a hold of me from there as well. Just simply send me an email. We'll go from there. All right. Thanks.